Hey guys, Mr. Milton here. Today we're looking at overlapping triangle notes. At the end of this video, you should be able to identify shared sides or angles in overlapping triangles. You should be able to redraw and accurately label two triangles from overlapping triangles. And you should be able to prove that two overlapping triangles are congruent. Okay. In these examples, notice how in each pair of diagrams below, there's at least one common part between the two triangles. Identify that part or parts in each. Okay, so shared parts, common parts, shared. Okay, and so as we look at these two triangles, and I'm looking here, I could redraw. There's a couple things that you can do to help yourself out. You can redraw the triangles, or you can notice them as they're overlapping. Okay, and so as I look at triangle ABC and triangle PRB, all right. First thing I noticed is that, hey, we have this angle B. That angle B is in both of them. Okay, and it's going to be the same angle. Okay, it's going to be the same measurement either way. And so there is our shared part between these two triangles. Okay. Number two, you should notice that when we have our overlapping triangle, as we look at LMP, or however you want to name that. Okay, and the other triangle, QPL. All right, you should notice that, hey, we have LP. LP is red and blue. It's in both of these triangles. Okay, and as you look here, you might say, oh, angle L and angle P. They are congruent, but they're not overlapping, and they're not the shared part. Okay, so there's a difference between being congruent and being shared. Okay. Just make sure there's no others. Okay, it's not. Okay. In this final triangle, there's a set of overlapping triangles. There are a couple things that we can notice just depending on where we're looking. Okay, as we look at triangle ADC, draw this really quickly not to take too much time, and triangle BED. Okay, you might notice that angle D is in both of these triangles. Okay, if we look at another set of triangles, like let's say AEB and CAB, then we'll see that, hey, AB is in both of those. They're overlapping and shared. Okay, and what this helps us to do as we look at overlapping triangles is it helps us to use the reflexive property to prove that two parts are congruent. And so a lot of our shortcuts call for us to need three of them. All of our shortcuts calls us to need three congruent parts. And so if we can identify those in overlapping, then that makes it a little bit easier for us to find those. Okay. All right. So when you've identified the shared parts, you have one congruent part of the two triangles because of the reflexive property. Just said. Then you only need two more congruent parts to prove that the triangles are congruent. Okay, so let's look at some proofs. This is called a flow proof. Basically a fill-in-the-blank proof, how we'll use it. You could do this if you wanted to, but I don't think we'll be writing proofs enough that you'll want to choose to do this. Two-column proof is typically the better way for us in our level. So some given information, they tell us that angle T is congruent to angle R and PQ is congruent to PV. And then they ask us to prove that angle PQT is congruent to angle PVR. So here we go with this prove. And they're not asking us to prove that two triangles are congruent, but two parts of triangles are congruent. So typically, that's a hint that we probably will need to use CPCTC. Okay, corresponding parts of congruent triangles are congruent. So let's walk through this proof. Angle T is congruent to angle R. We know that because it's given information. Angle T, angle R, already marked for us. Okay, angle TPQ TPQ is congruent to angle RPV, because, well, as we look at these two triangles, TPQ, RPV, and what I'm going to do with overlapping triangles a lot of times is I'm going to redraw my triangles. And the reason I do that is as I'm trying to identify why triangles are congruent, I will want to make sure that I can visually see what is happening. And so a lot of times I won't be able to do that with overlapping, and just because how my brain and eyes work. So we have PQPV already marked for us. We have angle T and angle R already marked for us. And now this final, or this statement here, TPQ, give it 2 hashes, RPV, give it 2 hashes, is now marked for us. And the reason we can say this is the reflexive property. Even though we named it differently, we're still talking about that angle P, this overlapping angle P. Okay, so you might see that here already, but when you're trying to, we'll talk about it. And then PQPV is given, sorry, not reflexive. It's given information here. Okay. So now when we're trying to identify why can we say that these two triangles are congruent, if we look at this diagram here, it looks like angle, side, angle, because we have an angle marked, then we have a side mark, and then another angle mark. And the side mark is between our 2 angle marks. Okay, and this is the importance of being able to redraw it. When we look at the triangles separately, we'll notice that that side that's marked is not actually in between the 2 angles. So it's not an included side. Okay, so drawing these without them being overlapped helps us to correctly identify this reasoning for saying that these two triangles are congruent as angle, angle, side, and not angle, side, angle. Okay, so even though it might seem like, oh, that seems like extra work for no reason, there is reason. So now we can identify correctly that it's angle, angle, side. Okay, and so now we've proven that the two triangles are congruent, and we get back to CPCTC, because PQT, as we look at it, talking about this angle here, and PVR, talking about this angle here, weren't used to prove that the two triangles are congruent, but now that we know they are congruent, they're corresponding parts, so they must also be congruent. Okay, it can be very confusing trying to answer angle D, so it might be a good idea to redraw the triangles. That's what we just talked about, but I know that you'll want to have this written down for yourself as you look back about it. Okay, we got some proofs to go through. Redraw and label below. You can do that again if you'd like to. We've already done that on the previous page. Okay, but if you didn't, here's some space. If you're like, oh, that's really cramped, I wish you gave me some more space. So there it goes. All right, so let's go through some proofs. Here is asking us to prove that triangle QDA is congruent to triangle UAD. So as I'm looking at this QDA, and sometimes it's a challenge to know which triangles you need to redraw and focus on. And here it's not going to be, because they've told us that you're using QDA and UAD. Okay, so UAD. Okay, now it is very important to make sure that you label your sides correctly. I do try to spend some time so that I'm drawing them how I see them. I don't want them to just be stacked, because sometimes you'll mess up your correspondence that way, but however you get it done, as long as you're redrawing it and understanding it's good with me. So the given information that we want to make sure that we start and use, they told us that QD and UA are congruent. QD is congruent to UA. And that was given information. Remember, it was given to us because of the diagram, not because of a given statement. Another piece of given information, they told us that angle QDA is congruent to angle UAD. QDA is congruent to UAD, also given. All right, so both of those. And now as we're looking to try to prove that these two triangles are congruent, we're going to need a third piece of information. Now they don't tell us anything else, but we do see that DA is a part of both of these triangles. And so it should be congruent to itself. DA here, DA there. And so as I'm looking at this, and I'm just going to make sure I use my statement to do this as well as possible, I should be able to say that DA is congruent to AD. And why can I say that? Well, it's a part of both triangles. That's the reflexive property. And so now I can say that these two triangles should be congruent. I have three things, right? All three of my things were something's congruent to something else. So these two triangles that they asked us to prove, QA or QDA, is congruent to triangle UAD because of side, angle, side. And that's it. We've proved our two triangles congruent, like they've asked. All right. Next problem. They're asking us to prove that ED is congruent to CD. So ED, CD, looks like these two triangles. Now, as we look at these, I'm going to take a guess. Hopefully I'm right. Say that EDB is probably the triangle that we're going to focus on. EDB. And, okay. And what's the other one? DCA. ACD here. Okay, so I'm going to think that these are the two triangles that we're going to be focusing on. And so as I'm looking at that, I'm going to start with the given information. So they told us that EB was congruent to CA. Okay, good. And they told us that angle DAC was congruent to angle DBE. Okay, so both of the information that they gave us are in these two triangles. So it makes me think, okay, I probably chose the right triangles. Okay, remember that we had other triangles that are overlapping here, and so there's a possibility that we need to focus on other triangles. So we need to make sure that that's what we're looking at. But as I'm looking at these two angles, or these two triangles, I should recognize that, hey, I have this angle D that's overlapping here, right? And so I have that angle D, that's going to be the reflexive property as we go through that proof. Okay, so I have angle, angle, side. This clue that they're asking me to prove that two parts are congruent, remember, is a clue that I'm probably going to have to use CPCTC at some point. Okay, and so that's prove that these two triangles are congruent, and then ED would be congruent to CD, great, because of CPCTC. All right, so there's my plan. Have my plan written down, and so now I can go through my statements. I'm going to start with my givens, and my givens are that EB is congruent to CA. Given. From there, I can go my other given, that angle DAC is congruent to angle DBE. Given. Number 3, I can use my reflexive property because now I say that angle ABDE, call it that, angle BDE is congruent to angle ADC, and that's the reflexive property. Okay. And so now with this information in my separate drawing, so it's easy to visualize what's happening, I can say that these two triangles are the same, and I'm going to be really careful to make sure that my congruent statement lines up, because if it doesn't line up and I can't prove this, then I can't prove it. Okay, so I'm going to make sure you do the right congruent statement. BDE, go from one arc to two arcs, is congruent to triangle ADC, one arc to two arcs. And that's because I have angle, angle, side. The side is not included. So that's why I use angle, angle, side and not any other thing. And so now that I know that those two triangles are congruent, then I can say that these two corresponding parts are congruent. So now I can say that ED must be congruent to CD because corresponding parts of congruent triangles are congruent. Okay. All right, for this note section, I'd like you to try this last problem. Okay, try this last problem out, and we'll do this in class. It is a very difficult problem, but I think that this If you can get this right, you'll have like confidence galore, okay? And it's going to be a good segue into us being totally independent with these proofs and being able to do whatever we need to. And that's a great way to finish our chapter, okay? So try this out. We'll go over it in class, and I will see you.